Previously, in Globally Speaking.
Statistical would win on accuracy and neural wins on fluency.
Google alone translates more words in a day than all the translators in the world translate in a year.
So what happened is with neural is that the 1 million line of code that was statistical now are only 280 lines of code in neural.
Welcome to Globally Speaking, your program that explores everything and anything to do with language localization. Are you ready to dive into the most critical issues impacting global brands today? Globally Speaking is designed to educate, inform, and challenge everyone who's engaged in global communications. Your hosts for Globally Speaking are Renato Beninatto and Michael Stevens. Learn more by visiting our website at www.globallyspeakingradio.com. And now, here are Renato and Michael.
I am Renato Beninatto.
And I'm Michael Stevens. And in part one of this series, we looked at the general concept of neural machine translation. We discussed the difference between rules-based machine translation, phrase-based statistical machine translation, and how Neural MT takes this approach to another level.
My name is Alon Levy. I am a senior manager for applied science at Amazon and currently lead the Amazon Machine Translation Research and Development Group, located primarily here in Pittsburgh, Pennsylvania. I was a professor at Carnegie Mellon for 20 years, where my research focused primarily on machine translation and natural language processing more broadly. And then I had a technology company that we spun out of CMU in 2009 for machine translation, particularly for enterprise machine translation by the name of Safaba. And that company was acquired by Amazon in summer 2015, and now we are part of Amazon, and where I'm leading machine translation research and development.
Based on his experience in MT, both from an academic and an enterprise perspective, we asked Alon about the evolution of the different systems.
So very interesting things there. I think machine translation, if you look historically at how the technology and the research has evolved from the early days where rule-based machine translation kind of ruled the game, and then we moved with the data revolution to statistical models, initially simple and then more complex statistical models that are trained on data, and now to this neural approach. It's always been more evolutionary than revolutionary in the sense that it never really was the case that something swept in was a complete solution to all of our problems or a huge solution to things that were not solvable before, and then within 6 months replaced what was there before. It was always much more evolutionary than revolutionary. And I think that is in fact true and will be true also for the neural technology. So significant advancement. It will take time to actually make this work, particularly in enterprise settings in a scalable way. And it will replace, I'm guessing, the current dominant statistical machine translation technology over the next 2 to 5 years, probably.
So, Michael, we see that technology is improving at a very fast pace. It took decades for machine translation to move from manually inputting dictionaries and grammar rules into computers to looking into large corpora of parallel content to identify patterns and correlations based on the frequency of use of words and sentences. In the last 10 years, Google Translate revolutionized the concept of MT by making a generic version of it available to everyone for free on the web. Now Alon is telling us that Neural MT will replace Statistical MT in 2 to 5 years.
What took 10 years, now 2 to 5 years. And Renato, the computer processors increase their speed, the capacity is increasing exponentially, and while all this is happening, prices are slashed. So we have the opportunity to deal with large volumes of content in an affordable way. This is what makes Neural MT possible today, affordable and fast computing capacity. But Alon Levy expressed some reservations about its application in the enterprise environment.
One of them is that fundamentally, we don't have yet very good control or understanding of what these systems are actually learning. So even though the training process of statistical MT is significantly more complex and involves several, a significant pipeline of components and steps, particularly in enterprise settings, where we're not just translating simple sentences or strings, but we're translating structured content, documents, material that needs to be often MT used in the context of machine translation plus post-editing to get basically a technology deeply integrated into generating human quality translations. It's actually quite important to have significant control over the translation process of what the machine translation is doing, being able to integrate deeply terminology, for example, or force translations to be generated in a particular way in a deep integrated fashion, be able to handle complex structured documents like web pages, Microsoft Office documents, anything coming today from content management systems. So it's a much more complex problem than just inputting, a text sentence on a UI and getting the translation for that in another language in simple text format. And those kinds of things are much more difficult at this point to do with neural MT. I don't think that this is, that those aren't necessarily the biggest challenges in terms of the technology, that those things are solvable, but it will take some time.
We heard from several people that one of the biggest barriers for the application of neural MT in professional environments is that it makes mistakes.
On the other hand, there's significant challenges when we're doing that because we don't actually have really any real control over what those internal representations that are being learned look like. And consequently, the technology, the way it is, at least at this point in time, it makes very, very strange types of mistakes in terms of translation because it's not a direct mapping between the source language and the target language in terms of the words and the sequences of words. Then it can make very, very significant mistakes in terms of the actual meaning. And so we have much less control over the mistakes that these systems are doing. They are currently very exciting because of that approach and the fact that it has the potential to solving the many language translation problem in a very interesting way. And because they've been actually quite successful, at least from what we've seen so far, in generating translation output that is much more fluent in the target language because of the fundamentals of this approach. But when it makes mistakes, particularly, I would say, when we need accurate translation in very specific domains and things like that, it can make very, very, very bad mistakes. And those are very hard to actually detect and predict because of the way the architecture of these systems currently is designed.
Hi, I'm Diana Riley. I head up global sales and marketing for Iconic Translation Machines. I think one of the key points is that there's a lot of hype about machine translation at the moment. And as you mentioned yourself, there's lots of media outlets who are publishing a lot of information about lots of different organizations who are claiming to actually be doing something with neural machine translation. But if we actually read between the lines, in a lot of instances, there isn't actually anything of real substance in a lot of those cases. But there are a few organizations who are actually doing some testing on it right now. And I think one of the key points is that at the moment it's testing. So at the moment, what we've been doing is that systematic comparison between current system and a neural machine translation system. So in terms of the time frame of when these systems are going to come online or how they're going to come online, I think there's a lot of different factors that have to be taken into consideration. So we've just been having a very technical discussion. So is it going to make it better? Yes, it will make it better. It's not going to be a silver bullet. It's not going to sweep the board. We're still going to be using statistical for some languages. And maybe it's just components that will be integrated. But I think some of the other key things that people are going to have to think about in integrating neural machine translation into newer systems that are coming online are more from kind of the practical point of view. So I think there's a lot of factors that need to be taken into consideration before organizations can just say, right, okay, here we have lots of systems that are out there. And at the moment, I think it's probably a little bit too early to comment on exactly how or when everything's going to hit the market. But certainly the key thing that we're trying to do at the moment is to identify some neural components that could be integrated into the current systems that we have.
I asked Diane for an example of the practical application of neural MT.
Recently, one of the inquiries we had was, compliance monitoring for a financial institution, which is fantastic because they wouldn't have considered using machine translation before. But this is where we're starting to see new use cases. And I think with the new technologies that are coming out, so once, Neural is going to help with some of those languages that are a little bit more complicated right now for machine translation. And it's just going to make it far more accessible down the line. And we're going to see a lot more new applications of it within enterprises, which is where I think it's going to really be exciting, because I think it's going to actually explode because there's going to be so many more use cases for it.
It's refreshing to see that there's some applications already on the radar for neural MT, but I wonder about the language pairs.
I think we had a conversation with Marco Trombetti from MateCat about this topic.
So I tell you, so Google a few weeks ago released a neural MT for Chinese English. And we quickly tested it. And we also have been testing the other solution from Edinburgh that has been very, very powerful and won the last two competitions. And what we noticed is that in 70% of the cases, a human will say that the new machine translation is better than the one before. Better or equal, sorry. So it's like they're equal for most of the time, but neural is 2 times better than when the old technology is winning. So there is some cases where the old technology is still winning, 30% of cases. There is maybe 20% cases where they're equal, and the remaining 60 is where neural is winning. So 50. So total would be 70% of the time better or equal neural. So in terms of quality, from a human judgment, it is better. Okay. And now I think that there is interest because it's just a little bit better. But the problem is that is the efficiency of how you convert human time, developer time, into quality. So now the engineer has a lot more time to think about how to improve it because it doesn't have the maintenance of that 1 million lines of code. Yes, the maintenance of 250 and all this time to plan how to improve it. So that's the future looks better for this reason.
What I'm hearing is that neural machine translation is great from the technology side, but not necessarily from the language side. So when we look at rules and statistical-based machine translation, we see that there are some languages that are not good at all for machine translation. That Finnish and the traditional Chinese or Japanese are very hard to do. With neural machine translation, will there be significant improvements in these languages that are hard to do with statistical and rules-based?
Yes, some of those languages will be improved. Just because they were different, no one worked hard to learn the machine how to learn. And so since no one was working on them, neural will do the job for the human. So they will get better in some of those languages. But also what is very interesting is the new way of working allows us in the future to do new things. For example, so we know that in translation, first, translation is one of the most complex things for a machine to learn. Now, it's a very compressed way. Now we express a meaning. So we have something in mind, we convert it into words, and then you understand what I mean by having a lot of references outside the sentences I said. You have links to the knowledge, the experience you have. So we cannot think that in the future we still teach machine just on written text. So we should feed the machine with videos, images, the entire experience that the human being had if we want to perform at that quality. So with neural, it becomes easy to say, okay, here's YouTube. Take everything that you see in YouTube and classify that information and connect this information with this text. And so you can start distinguish and do disambiguation of words, of meaning, by the fact that those represent 2 different images, for example. And the machine is able to learn those things without any effort from the developer. And that creates the possibility of feeding the machine with data that were not possible before.
One of the claims to fame of neural MT is that it creates its own interlingua and can translate content for languages without parallel corpora. So theoretically, with very little input, NeuralMT could translate, say, from Latvian to Swahili, your favorite language pair there, Renato. I asked Mike Dillinger from LinkedIn if this feature would bring benefits for long-tail languages.
Definitely. So if you think of projects like Translators Without Borders, where they have to try to do some sort of machine translation and human translation with very long-tail languages, the current approaches, which require lots and lots and lots and lots of data, just don't apply. So you have to do something that's kind of rule-based and with some sort of translation memory and make do with that. The other thing that we can't do at the moment is have the translators provide more general feedback. For example, at eBay, when we were translating things into Brazilian Portuguese, we found that the MT systems couldn't handle the diminutive suffix. Mm-hmm. So there's plenty of data to talk about capa, or a case for your iPhone, but many people described it as capinha, a little case for your iPhone. And in that case, the MT systems just fell apart because capinha was considered an unknown word, and then the systems didn't know what to do with it, and the translation quality really suffered. It would be really great if we could have something like a human translator say, hey, translation system, INHIA, the suffix is a suffix. And if you can't find it with the suffix, then try looking for the word without the suffix. So these general rules that leverage the human translator's expertise are the kinds of things that, as far as I know, we can't actually use in MT systems today.
Renato, I recently heard that creating neural machine translation is very similar to raising kids. You give a lot of know-how and data, but you have no idea what they're going to do with it.
Well, that's a great metaphor. The fact is that neuro-machine translation has left the realm of fantasy and academia and has moved into the realm of reality.
Yeah. And so now we're able to look at what is the impact on the language industry.
Well, you know that I'm an optimist. As I mentioned in our previous episodes, machine translation, either statistical or rules-based, already handles more words in a day than all human translators process in 1 year. For me, the real question is how we harness the power of machine translation to make the translator more productive.
In the next episode of Globally Speaking, we are going to talk more about humans and machines working together. We're also going to address the practical concerns of buyers and suppliers, like confidentiality and pricing. You don't want to miss this one.
Globally Speaking Radio is produced by Burns 360. You can subscribe to Globally Speaking on iTunes or wherever you get your podcasts. You should also check out our archives at globallyspeakingradio.com, which has every past episode, including transcripts. You can follow us on Twitter and on Facebook, and feel free to share ideas for shows with us. Thanks for listening.
Thank you for listening to Globally Speaking, brought to you by Moravia. We'd like to hear your comments, suggestions, and feedback. So until next time, please visit online at www.globallyspeakingradio.com.